Hello everyone, my name is Rui Wu, a PhD student from UMass Law, Electro and Computer Engineering Department. I'm very glad to have this opportunity to present our poster on Project 1.5, Distributed Sensing Textile for Bridge Monitoring. Let me briefly introduce our fiber optic lab. Our group led by Professor Xinwei Wang, and our focus research area are optical fiber sensors, biosensing, and mobile devices, and also optical imaging. And Professor Ziyang Yu's lab from Department of Civil and Environmental Engineering, they are experts on remote sensing and concrete structure analyzing. Structural health monitoring allows the observation of structural characteristics to save lives and reduce maintenance cost of the infrastructures. Boolean time domain refractometer has attracted increased interest because its distributed measurement capability. In this project, we designed and fabricated the fiber sensing system using BOTDR technique and demonstrated the test on the actual bridge. As shown in Figure 1, the Semaphore River Bridge located in New Hampshire, and we have train passing by the bridge. We install the sensing textile at the bottom side of the bridge, which you can see the red box indicate that the sensor's location in the third picture. Here is the schematic of the fiber sensing system. One straight fiber with U-shape was distributed across the textile, and total length was 22 meters. The BOTDR machine was connected to the fiber out of the sensing textile under the bridge. Let's see how we install the sensing textile. Experts from ARE help us to install the sensor under the bridge. First, they polish the steel plate to clean the surface. Then, they applied epoxy to sensing sections. After fixing the sensing textile, they used brush to remove the bubbles in the epoxy. The epoxy took 1 day for curing, and we began collecting BOTDI data after that. The technique we use in the fiber sensing system is called Boolean optical time domain refractometer. Boolean frequency takes place when a photon from an incident light wave is transformed into a scattered photon. The optical frequency of the backscattered light by the Boolean scattering is up or downshifted from the incident light by the Doppler effect. As shown in Figure 3, when fiber was applied with strain or temperature change, the Boolean frequency will shift it, and by monitoring the frequency shift, the whole fiber can be a distributed fiber sensor. Here is the BOTDR signal we collected from the bridge. As shown in Figure 4, the DA part was the connecting fiber hanging down from the bridge. The section ACB is the sensing section, and the point C was the U-turn part in the design. The BE part we use as a temperature compensation part, since they are not fixed in the epoxy and free from pre-strain. The sensing section ACB has a total length of 22 meters. After installation of the sensing system, we continuously come back to the bridge and recorded the data over 22 months. Only the sensing section was shown in Figure 5, and they were all using the same parameters and continuously recorded 5 times in each test. The data trend was in a good agreement with each other and represent that the structure of the bridge was in good condition as we expected. These data result indicates that our system is durable and can working under different weather conditions in a very long term. Furthermore, we put all data in one plot after temperature compensation and do more analysis. We found that the big noise appears on junction 1 and junction 2. We can see those junctions on the second picture of figure 6. The gap between different pieces of steel can cause the dry out of epoxy, and also the junction sections are more sensitive to strain. So the unstable noise was introduced to a system at these two locations. In conclusion, we designed and fabricated the fiber sensing system embedded in sensing textile with Saint-Gobain. We installed the sensing textile under the Semaphore River Bridge with ARE. We also collected BOTDR data signal from the bridge over 22 months. The sensing system survives under different weather conditions and functions properly. BOTDR signal performance can be improved by increasing step frequency. And also, BOTDA technique will be added to comparison in the future. Thank you so much for your attention.